Yeah, is my voice is audible?
Yes, ma'am. Madam, shall we start the session, ma'am?
Yes, I am ready.
Yes, ma'am.
Shall I start it?
Yes, ma'am.
Yeah. Is my screen visible?
Visible.
Prakash sir, shall I start the session?
Yes, ma'am. You can start the session, ma'am. Thank you, ma'am.
Right, thank you. Yeah, very good morning to one and all. Today we are going to discuss about the importance of data analytics for recommender systems. This is Indira, Associate Professor in the Department of Information Technology in SRGEC, Gudavaleru. Yeah, coming to the topics, today's topic, what is big data and what are the recommender systems and what are the existing recommender system and the filtering algorithms and new algorithms for different types of data structures. Yeah, I will cover up to the existing recommendation systems and the problems, and I will not in deep concentrate on the new algorithm. Just I will brief it. That's it. Coming to the coming to the big data. First of all, we will see what is data. So what is data means? It is nothing but it's a collection of facts and statistics collected together for a reference or analysis. Generally, we can term it as data is a raw material. And on the data, we can do different things like we can collect the data and store it in the form of relational databases or hierarchical databases or NoSQL databases. Like this, we can store in different forms. And we can apply some measuring algorithms and we can calculate the distances on the data. And we can apply analyzing techniques by using machine learning algorithms, and we can represent in the form of graphs, visualization. So all these things can be applied on the data. Coming to purely the purpose of the data is to extract the knowledge. Why we need to store the data? See, if you generate a voice call, so many calls are there, but why the providers, why the BSNL or Airtel users, why Airtel or so many providers, why they are storing all these calls means that to extract some knowledge. So we need to link all the data and all the types of data. And data is not in the form of a digit, or the data is not in the form of a string, or the data is not in the form of a graph. So if you observe the right side diagram, you can see the data may be like a waveform, or the data may be a satellite data, or the data may be a DNA data, or the data may be social media data. Yeah, in our previous discussion, we discussed about the social media data, and the social media data is like from Twitter or YouTube and all these things. It's only one part that says it's a social media data. So data is not only social media data, it may be collected from different sources and different sensors. So we need to collect, or we need to link all these types of data. Now coming to big data. The amount of data that is beyond the storage and processing capabilities is called as big data. The amount of data that is beyond the storage and processing capabilities is called as big data. And we cannot store it in a single machine. So the theme of FDP is data analytics, data privacy, and data security. So if you want to apply data analytics, definitely we need to go with big data. By means, we cannot store the data in a single machine. So definitely we need some storage capabilities and processing capabilities beyond a single machine. That is called as a big data. The term big data is nothing but a collection of data sets of so large and complex that it becomes difficult to store and process using on-hand database management tools or traditional data processing applications. See, we already have some database applications, like we have already Oracle, we have already MySQL, and we have already Sybase, and we have already simply MS Access. But all these are not sufficient to process the applications. That is called as a big data. Coming to once again, one more definitions. All the organizations, they entered into the new era, and which is called as big data, means that to uncover it out of the way information. So coming to the big data, shall I say it is in the form of gigabyte or terabyte? So in which area we can call it as big data? In which area it is called as only simply data? See, if the amount of data is more than hundreds of terabytes, if it is only 1 KB, no problem, it is not big data. If it is 1000 KB, it is not big data. It is 1 MB, it is not big data. It is 1 GB, it is not big data. It is 1 TB, it is not big data. But if it is hundreds of terabytes, thousands of terabytes, then it is called as a big data. So the amount of data is more than hundreds of terabytes, then it is called as a big data. So you know what is gigabyte? It is 10 to the power of 9. What is terabyte? It is 10 to the power of 12. If you start from a byte, it is 8 bits. It's also called as 1 byte. So you know 1 KB, 1024 is 1 KB. And you know what is MB? It's 1024 is 1 MB, right? 1024 MB is 1 GB. You know all these things, right? So in the form of 10 power, if you say 10 to the power of 9 is gigabyte, and 10 to the power of 12 is terabyte, 10 to the power of 15 is petabyte, and 10 to the power of 18 is exabyte. So coming from the petabytes, we can say it is a big data. Now coming to the characteristics of big data. First, suppose if the data is huge, if the data volume is very high, then I can say big data. No, not only like that. So many characteristics are there for the big data. So we have all the characteristics of the big data are categorized previously only three V's. We can say three V's. One is volume, and the second one is variety, and the third one is velocity. Now some more V's are also added. 5 V's, 6 V's, 9 V's. So many V's are there for the big data. So one is volume. The volume is nothing but the size of the data. Next one is the velocity, the speed at which the data is generated. Third one is variety, the different types of data. Veracity, the trustworthiness of the data. And the value, that is nothing but you are going to calculate the value, and we are calculating the usefulness information into a particular value. And the last one is variability. It is a 60V. All these are the different characteristics of big data. Coming to the 5Vs of data, coming to the volume, terabytes, and we can consider it as a collection of records or transactions or tables or files. Coming to the velocity, it is nothing but the batch one, real or velocity means time to time, time to time. See, if you observe, today's weather is 36, tomorrow's weather is 37 degrees. Like this, the temperature is varying from time to time. So the time to time information is called as velocity. So we cannot consider this is the exact value for this particular point or for this particular information, right? So it varies from time to time. Transactions are also values. First, suppose if I have 1 lakh rupee, if I withdraw some 10,000, it is only 90,000. So if I stand to 1 lakh, it is not correct. Definitely, I have to consider the withdrawal amount also based upon the time. So that is called as a velocity. Coming to the value, we have to use statistical formulas to get the value from the information, and correlations, hypothetical informations are all values. Coming to the veracity, it's nothing but trustworthiness. Means that suppose if you observe some blogs of data, or if you observe the reviews, it may be correct or it may not be correct. It may be posted by the true people or it may be posted by the worst people. So credit card informations. So all these are the coming to the veracity. It's also one of the characteristics of the big data. And coming to the variety, so structured, semi-structure, and unstructured, and multi-factor, and probabilistics. All these are the different types of big data. Types of big data. So here the V's are characteristics of big data, and the types of is nothing but the variety of big data is structured data, unstructured data, semi-structured data, and multi-factor data. So coming to the properties of big data, the properties of big data is nothing but, see, I think you know the database management system properties. So 4 properties are there. ACID properties. ACID stands for atomicity, consistency, isolation, and durability. But coming to the big data, the characteristics are different. It is nothing but base properties. So what are the base properties? Nothing but base properties are based upon the CAP theorem. So what is CAP theorem? The CAP theorem is C stands for consistency, A stands for availability, and P stands for partition tolerance. So see, these ACID properties are nothing but related to RDBMS. The base properties are nothing but the NoSQL, and coming to the big data properties, CAP properties are there, or we can say it as a CAP theorem. C stands for consistency, P stands for partition tolerance, and A stands for availability. So coming to traditional data warehousing or traditional data, we are concentrating on query languages, OLAP and OLTP. Coming to the big data analytics, definitely we are moving towards machine learning, natural language processing, statistical processing, predictive analytics, in-memory analytics. So what is the comparison between the previous data warehousing or database models and big data is nothing but simply we are using SQL is enough, OLAP is enough, OLTP is enough for the traditional things. Coming to the later ones, machine learning concepts and NLPs are very important. So what are the organizations, different organizations which are using big data services are NASA, New York Times, Amazon, Google, Twitter, what else? Everyone, every software company, they are using big data services. So what are the different areas which are covering under big data is nothing but scientific exploration. I'm not concentrating much more on the each and every one. And coming to the healthcare and governances, governance means surveillance systems. I think everyone know about today's every city is covering with surveillance, video surveillance, electronic surveillance, or webcams. So we are maintaining webcams in the cities, and if any theft is there, if any abnormal situations that occurred in the city, they can use all these videos to analyze and to classify the streaming data, acoustic signals, and transportation departments. All these departments will use the surveillance system input, right? And financial and business analytics, know that everyone. So today's stock market, tomorrow's stock market, and the commodity markets, everything depends upon the big data analytics only. Web analytics. Web analytics are nothing but several websites are experiencing millions of unique visitors per day, in turn creating a large range of content. See, so first suppose if I am the new customer for the Amazon, or if I am the new customer for the Flipkart, it will give some recommendations to me to get the information from the website. First suppose if I am a new person to the Amazon, it will give recommendations like these are the based upon my preferences, previous website visits, it will give the recommendations, right? So this is called as web analytics. This is one of the area of big data. So coming to the big data taxonomy. So the big data taxonomy, big data is not only related to a simple data or simple characteristics of data like volume, velocity, variety, and all these things. It's a collection of file system, technologies, tools, schedulers, data dimensions, analytics, programming models, security, commercial frameworks, and open source frameworks. So coming to the tools, it's a combination of NoSQL, SQL, graph, and spatial. And coming to the schedulers, query schedulers and data incentive is there. And data dimensions, it is a collection of variety, structure, semi-structure. And coming to the analytics, web mining, text analytics, in-memory analytics, video analytics, predictive analytics, so many categories of analytics are there. Coming to the programming models, we can use MapReduce programming model, or thread model, or task model, or data intensive model, or BigQuery model. Right. Coming to the security, secure computing, authentication, and privacy preserving auditing is also there. Coming to the commercial frameworks, Google, Panas, Aneka, Oracle, all these are the commercial frameworks. And coming to the technologies, it's a Hadoop, Spark, and all these things. So I'm not concentrating on the Spark and all these things. So directly I'm moving with the introduction to the recommender systems. So today our topic is what big data analytics, the importance of the big data analytics for the recommendation systems. So yeah, I already explained you the type of data. Social media data is only one type of big data. Social media data is only one type of big data. So we have so many data like streaming data, sensor data, like DNA data, satellite data, spatial data, text data. So many data are there, right? So all these data can be used to recommend the product or item to the public. So why the people they are maintaining, see, software companies, the providers, they are maintaining big servers to maintain the data. They are maintaining servers for maintaining of data. They are facing so many problem. See, nowadays we are also facing problem. So till now we don't have any problem with our Gmail accounts. Even though if we have 15 GB of free account for us, so happily we share the mails from one to each other. But if you link your phone to Google account, they are storing all your photos, phone photos to Google accounts. So automatically they are occupying your memory, cloud memory. So storage is also very crucial. Storage is also very important. So that's what so the providers, they are maintaining cloud servers for maintaining of big data. Why we need to maintain the big data? For giving recommendations, for maintaining recommendations. So today's topic is introduction to recommendation systems. So here everyone know about the maintaining of information in the cloud. So there are some cloud servers. The cloud server, so there is an extensive class of web applications. There are extensive class of web applications that involve predicting user responses to options. Predictive user responses to the options. I will come later. So here, the purpose of the recommendation system is it has the ability to predict whether a particular user would prefer an item or not based on the user's profile. It has a ability to predict whether a particular user would prefer an item or not based on the user's profile. I have a profile. I'm a teacher. I have a passion. I have some interests. But if I watch something new, even though I am my profession is like teacher, it will give recommendation related to the watched information. Means, first suppose if I watch a medicine information, it has to give the recommendation like about the medicines, right? Regularly I will check for particular subjects like what is flat or new technologies in computer science, new technologies, new softwares in computer science, new items in hardware information, what is IoT, what is AI, what is deep learning. Like this every day I'm searching for that one, no problem at all. But today I searched for one particular medicine in the Google. So from the next time onwards, it has to give a recommendation on the related medicines. That's the concept of the recommender system. So it will give the uh, it has to predict the information even though particular item is not searched by the user. That's very, very important. Recommender systems are beneficial to both service providers and users. See, so the recommender system is not confined to the provider or not confined to the user. It is very beneficial to the both the people. So need of recommender systems for service provider, for the user, service providers, and for the user. For the service provider, it helps in deciding what kind of offering should be, and it helps in choosing among a large number of articles for the user. What are the types of the recommender systems? The recommendation systems are categorized into two: personalized recommendation systems and non-personalized recommendation systems. Personalized recommendation systems and non-personalized recommendation systems. And what is a personalized recommendation system? The personalized recommendation system considers the preference of users to be recommended. Yeah, I am already explaining you like that. Recommendations, preferences. The personalized recommendation system considers the preferences of the user. They're considering the preferences. What are my preferences? It will consider. But non-personalized recommendations will not bother about my considerations. The most recommendation methods are personalized. The personalized recommendation system utilizes the characteristics of the items, profiles of the users, and the interactions or transactions between the users and items to predict the user's future item adoptions. So, every personalized recommendation system utilizes the characteristics of item. What are the characteristics of items? If item characteristics are similar, they will recommend. It will identify the profiles of the users, the interactions among the users, the transactions between the users. It will consider all these things. Coming to the non-personalized recommended system. The non-personalized recommended system, however, do not make use of the user preferences. Non-personalized recommended systems, however, do not make use of the user preferences. An example of non-personalized recommendation method is to return top 10 songs of the current month. So recommended approaches. If you go with the recommended approaches, so here we are considering item hierarchy. Suppose if you bought a printer, you will also need an ink, right? If we buy a printer, if the ink that is present in the printer is finished or out, then definitely we need ink. This is nothing but item hierarchy. It depends upon it. So ink is the cartridge is not purchasing of cartridge is useless, nonsense. Purchasing of cartridge is nonsense, but the cartridge depends upon the printer. Purchase of only wheel is useless. If you go with a car, right, four wheels are there, then if there is any problem for one wheel, we will go with the Stephanie. That's nothing but the wheel is depends upon the car. So it is nothing but item hierarchy. Item hierarchy. So here we will go with the item hierarchies. How many printers are purchased by the people this month? How many printers are purchased by the people in the last year? Then the production of the ink or the cartridge must be placed based upon the printer purchase. Then coming to the attribute based recommendation. Attribute based recommendation. You like action, movies, starring, Clint Eastwood. You might like good, bad, and ugly, like this. So if you like attribute based recommendations, you like action movies, starring, like this. So coming to the collaborative filtering. Item similarity. You like Godfather, so you will like Scarface. Collaborative filtering. User similarity. So there are some similarities like item similarity. User similarity means that people like you who bought beer also bought diapers. Coming to social plus interest graph based. Your friends like Lady Gaga, so you will like Lady Gaga. Model based, training SVM, LDA, SVD for implicit features. Now coming to the applications of the recommended systems. The applications are movie Is it okay?
Yes, ma'am.
వచ్చేస్తా 10 minutes. నువ్వు బయలుదేరిపోతున్నారా? ఎన్నింటి బయలుదేరుతా చెప్పు. నాతో బయలుదేరిపోతా అంటే సిద్ధి బట్టి చేద్దాం అనుకుంటున్నాను. బాబాయ్
Hello, there is no voice audible from your side, madam. Voice is not audible.
Sir, there is an internal technical difficulty, sir. Please wait 2 minutes.
Okay,
any
sir.
problems, sir?
Yes, ma'am. Now it is audible, ma'am.
Is it audible?
Yes, ma'am. It is audible.
Okay.
Yes, ma'am, it is audible.
Sorry for the disturbance. Coming to the recommendation system, if anybody wants to generate a new recommendation system, what we have to do? See, if I launch a new product, then I need to provide a recommendation to my product. So in what matter I can do it? So first thing, I have to collect the feedback of my product. First thing. then only I can give the recommendation to the public. First thing I have to collect the feedback. So the first phase of the recommendation system is, it is very easy, the word recommendation system, but we need to implement. We need to give the recommendation to the targeted people. That's it. See, for suppose if a medicine, cough medicine is there, I can suggest this to the people, those who are suffering with the cough. That's it. But I can't suggest this one. I can't recommend this one. Those who are suffering with the fever, right? I'm taking the medical medicine examples. But first, suppose if I go with the food example, first suppose if one person, if the person is in the age of 6 months, I will suggest the food which is taken by the 6 month people. Means that what is that? I cannot suggest the meat. I can suggest only milk. That's it, right? Or milk products for the 6 months baby. First, suppose if the person is in the age of 8-30, I can suggest in the different manner. Means that further, the first phase of the recommendation system is information collection phase. In this information collection phase also, three categories of collection is there. First one is explicit feedback, implicit feedback, and hybrid feedback. After collecting the information or after collecting the feedback from the people or the public, definitely we need to generate the model. So this model is nothing but a machine learning algorithm model, or a deep learning algorithm model. This is called as a learning phase. So all the machine learning algorithms are applicable in the learning phase. Learning phase. Then coming to the last one, a prediction means that the identifying the new thing, or the recommendation phase. So predictive analytics and recommendation analytics are the third phase in the recommendation systems. Now, the input. What is the input to the recommendation systems? The input to the recommendation systems is explicit data. Definitely, in the learning phase, we are using machine learning algorithms. What the inputs we are going to give to the recommendation systems? We need to give explicit data. What is the explicit data? So we have to collect the explicit feedback. So what is the explicit data or explicit feedback? The explicit feedback is nothing but customer ratings. We are going to take the rating of the customer on the product by using any of the social media website or by giving the feedback form, definitely. So we have to take the customer rating, and almost if you observe, if you purchase a product, they will give a feedback form, and all the customer people, they will ask you, please fill the feedback, madam, please fill the feedback, sir, and Japanese. Like this means that they are going to collect the feedback. And demographics means that demographical differences and and physiographics and like this explicit data. Coming to the implicit data, so we have already implicit data like purchase history. We have purchase history in the Amazon. We have watch history in Netflix. We have watch history in Amazon Prime. Like this, the previous history, it is called as implicit data. And click or browse history, right? Coming to the next last one, product information. The product information is nothing but product taxonomy, product attributes, product descriptions. All these are the inputs that are going to give to the recommender systems. Coming to the categories of the recommendation system or the types of the recommendation systems and the recommendation system algorithms or filtering algorithms and techniques. Already we discussed the types of recommender systems are content-based recommender systems and collaborative-based recommendation systems. So for the content-based recommendation systems and collaborative systems, we need to apply filtering techniques or the machine learning algorithms. So for the content-based recommendation techniques or filtering techniques, we can go with TF-IDF, means that term frequency inverse document frequency. This is one algorithm or one technique to identify, we can calculate the recommendations based on the available data, or probabilistic models, or Navy-based algorithms, or the classifiers, or the neural networks. All these can be applied for the content-based filtering algorithms. For the collaborative filtering algorithms, The collaborative filtering algorithms are categorized into two: model-based filtering algorithms and memory-based filtering algorithms. The model-based filtering algorithms can be calculated or can be filtered with the clustering, association rule mining, and Bayesian networks. Coming to the memory-based filtering algorithms, we have to concentrate on user preferences and item preferences, or item based recommendations and user based recommendations. Coming to the last one, hybrid filtering techniques. The hybrid filtering techniques is nothing but hybridization, weighted average, switching, cascade, mixture, feature level, meta level calculations. All these are the hybrid filtering techniques. So coming to the recommendation systems, the three phases are there. First of all, for any system, we need to give input. I have to calculate the learning phase or the model based, and finally, definitely we will get the output. So in the recommendation system also, the input is implicit feedback or explicit feedback or hybrid feedback, and learning phase is nothing but all these are the techniques. So under the learning phase, second phase, learning phase. In the learning phase, we can go with content based filtering or collaborative filtering or hybrid based filtering. For the content based, I can go with TF-IDF or probabilistic or Navy Bayesian clarifier, neural networks, or some more new algorithm that are generated by ours. So all these categories of recommendations, they are suffering with some problems. They are suffering with some challenges. So these challenges can be addressed with some new algorithms. So what are the recommendation algorithms? The second phase, learning phase, they are using the recommendation algorithms. All these recommendation algorithms are TF-IDF or like this. So coming to the content-based systems, focuses on properties of items, similarities of items, determined by measuring the similarity in their properties. This is about the content-based system. Coming to the collaborative, we are going to calculate the relation between items, relation between the users. Right? Similarity items is determined by the similarity of the ratings of those items by the users who have rated both items. And coming to the last one, memory-based techniques. The memory-based techniques use the data, means like likes, votes, clicks, like this. This is nothing but hybrid. Model-based also called as a hybrid-based. All these algorithms, they are suffering with some challenges. Challenges. What are the challenges? Challenges of existing algorithms. They are suffering with sparsity. Sparsity means that all the data is not in the same form. It is sparsity. And the third one is cold start problem. First, suppose my product is very new. It's very new product. Those who know about our product, no, it's nothing but cold start. So if it is a old product, some people purchased, some people gave some feedback. So everything is available. It's a old product. But it is a new product launched by a new company. It is called as a cold start problem. Means that there are old users, there are old feedbacks, there are no old feedbacks, there are no old users. Then it is recommendation system starts with a cold start problem. The next one is scalability. Scalability means, okay, no problem at all. Now I have thousands of data, means the 1,000 records. I gave some recommendation. Now it is increased to 1 lakh. 1 lakh users are there for the particular product. 1 crore users are there for the particular product. Say, scalability. And the next one is change in data. Change in data means that preferences are modifying by the users. Preferences are changing. The last one is recommendation quality. So we are recommending, no doubt at all. But the accuracy is different. Recommendation quality is very different. So he is a man. If I suggest a product which is useful for a woman, is a bad recommendation. If he is a woman, if I suggest a product which is useful by the man, is a bad recommendation. So recommendation quality is also very important. And change of user preferences. Then we can't do anything. Every day to day, the user preferences are changing. Nowadays, every people, they are concentrating only on the luxury. They are not concentrating on the cost. But some people are there, they're concentrating only on the cost. They are not bothered about the quality. Like this, the change of the user preferences also considered for generating of the new algorithms. So now we can go with the new algorithms that are not there in the listed, called as existing algorithms on the top of Hadoop, and attribute tagger, and Twitter polarizer, and short-term classification, and short text classification, hashtag based, and we can go with the new recommended system on the Twitter contents. So almost the people, those are in the first class, they will use the Twitter for giving their uh, feedback. That's why tweet content recommender is a new algorithm that we generated for giving the recommendation. And these recommendations can be applied in structured data, semi-structured data, and unstructured data. So coming to the first one, first suppose if I'm going to give a recommendation on the structured data, minutes. So first, for coming to the structured data, recommending a product or service based on the historical data. So for this, we can use instance filtering algorithm and nearest neighborhood algorithm for collaborative filtering. And coming to the second one, semi-structured data, we can go with the natural language processing, semi-structured data. For unstructured data, we can go with the tweet polarizer algorithms or tweet content recommender algorithms for the unstructured data. So all the recommendations can be applied for text structured data, semi-structured data, and unstructured data. For the structured data analytics, we can go with like this. We are going to take the input data and we have to apply the data pre-processing and we have to apply the data transformation, and they can combine with algorithms like two algorithms. One is instance filtering algorithm and the second one is the nearest neighbor algorithm for the structured data processing. So we collected one data set called as the airline data set by using the Hadoop environment, and it consists of so many parameters or the features, and we considered only the features which are applicable to for our application, and we used some service rating algorithms for calculation of the distance travel from aeroplane from one location to the another location. Which one is the best one? First, suppose if I want to travel from Vijayawada to Hyderabad, so which aeroplane is best for me to travel? So if I'm an economy person, definitely I need a cheap ticket, a less amount ticket to travel. I don't want to bother about the time. So if it is only 2000, I will make changes to travel time. So I can go by evening or I can go by the night also. But if I'm a very powerful person, I have very precious to the time. I don't bother about the amount. Suppose if a flight is there, it will charge 10,000 rupees to travel from Gannavaram to Hyderabad. So it is very fast. It will drop by me only within half an hour. It will start by 10 o'clock. Then definitely I will prefer the first one. So we are going to use this type of consideration for giving the recommendation to the public by using service rating. So this is about the structured analytics. So definitely all the people, they can go with the Hadoop environment for calculation of any type of data, structured data analytics by using existing algorithms. Semi-structured data analytics, for the semi-structured data analytics, definitely any document can be collected with the different sources, and we will give with the diagram, and we will generate the visualizations. And for any algorithm, data gathering is there, data pre-processing is there, algorithm definitely we have to apply, experiment results are there. So coming to the unstructured data, definitely Twitter challenges are there. Everyone uses the Twitter for posting of the attributes, real-time streaming data. We have to collect the real-time streaming data, and based on the real-time streaming data, we will apply recommendation algorithms, and we will get the recommendations. We'll get the recommendations. And definitely we will get some type of experiments. Because of some time constraint, I'm not explaining so much. I'm not concentrating on the different things. See, I have to give some brief about the Hadoop, and I need some time to give what is Hadoop ecosystem and how we can execute all these things, how we can generate the recommendations of a new product by concentrating on the cold start problem and by considering the sparsity and scalability. I will cover in the next FDP if time permits and if you give an option for me. Thank you, one and all. Sorry for inconvenience, and thank you.
Thank you so much, ma'am, once again. In your busy schedule also, you were accepted our invitation, ma'am. Thank you, ma'am.
Thank you, Guy. Prakash.
Yes. Dear participants, today's attendance link is already posted in the WhatsApp groups. So kindly fill honor before 1:30, and there is no afternoon session. And it's time to give the vote of
Sir.
thanks. Sir?
Sir, when we'll get the certificate, sir?
Within 1 week, sir.
Okay, sir. Thanks.
Okay, it's time to give in the vote of thanks. A warm and grateful wishes to our most valued Honorable Vice Chancellor, Professor K.B. Chandrasekhar Garu, Rector, Professor D. Suryachandra Rao Garu, Registrar of Krishna University, Dr. M. Ramareddy Garu, Principal of University College of Arts and Science, Professor Y. Maruti Ma'am, Head of the Department, Dr. R. Kiran Kumar Sir, Dean, Faculty of Engineering and Technology, Professor Y.K. Sundarkrishna Garu, and all the faculty members of Computer Science Department, and all the fraternity of Krishna University who are here of the are all the attendees for these valedictory session. It's my privilege to propose a vote of thanks and acknowledge the contributions of those who worked really hard to make this FDP in a successful manner. I, Mr. Pagalla Bhavani Shankar, Assistant Professor, Department of Computer Science and Engineering, on behalf of Department of Computer Science, University College of Arts and Science, Krishna University, and the entire fraternity of the university, first of all, I extended my most sincere thanks to the Almighty God for making this 1 week FDP on data analytics, security, privacy, and its applications a resounding success. On behalf of the Department of Computer Science, I extended a really hearty vote of thanks to our Honorable Vice Chancellor Sir, Register Sir, Rector Sir, Principal Ma'am, Dean, Head of the Department of CSE, all the remaining coordinators, faculty members, Dr. M. Babureddy Sir, and Dr. R. Vijaykumari Ma'am. Thank you so much, ma'am, for your support and suggestions. We got this grand success. And I thank my co-faculty, Mr. PLN Prakash Kumar, who supported me a lot. And my special thanks to the all non-teaching staff members also. And finally, I would like to thank all the participants. Without it is not possible to celebrate like this FTP as a grand success. You are the foremost precious persons to this FDP. Thank you one and all. We will meet at the next forthcoming FDPs also by the God's grace. Thank you.
Sir, is there